Well, hello, let's get this going. Sorry for the long wait, the Windows machine was not happy. Anyway, I won't be doing this on Windows, I will be doing this on my Linux system, but if you want to do this more easily, you should probably use some tools that'll help you. Namely, you'll need Visual Studio 2019 Community Edition, and then you will need a beautiful little piece of software written by a guy called Malware. Yeah, don't worry about the name, he's a cool dude. But you want to get on his GitHub, most easily search for MDK command VM. Sorry about that. MDK space engineers. Add on GitHub to make it easier. Let that load. Yeah, this VM is not the fastest thing in the universe. It'll take it a hot second. Visual Studio doing stuff in the background is probably not helping. But yeah, you go to his GitHub page. If it ever loads. Wow, it's really being finicky today. Command Edge should have installed the browser. It's quite possible that Visual Studio is not helping any. Thank you! So on the right you'll see this releases thing. You just want to click on the latest. And you want to download mdk.vsix. And let me just... this thing, I already downloaded it. So it's in my downloads folder already. But once that downloads... oh, I forgot to mention. When you download Visual Studio, you can just Google for... yes? Hello browser? Yeah. Just search for Visual Studio Community 2019. Go to downloads. And just hit free download. It'll download an installer that will actually download the rest of the components it needs. Once you're in there, I took a little screenshot. If the only thing you need to do is code for space engineers, oh come on VM. Jesus, yeah. The only option you really need is this .NET Desktop Development. That's the only thing you need to mark. The rest of it you don't need for space engineers, at least. So you have your Visual Studio. You actually want to have it closed, I'm sorry. And go where your download is for the MDK plugin. Just double click it. And just click install. This will be much faster on your machine. This VM is really not doing me any favors. Come on. What are you doing? My CPU isn't even that hammered. Oh, for Pete's sakes. Okay, this is excruciating. God damn it, sorry. Thank you. Okay, so it installed. I'm gonna start Visual Studio again. Yeah, it's fine, Morpheus. I will leave the VOD. I'll make sure to mark it so Twitch doesn't delete it. Okay, so once you have MDK's plugin installed, if you click Create New Project, once it loads the templates, it'll show the in-game script project type. So this does not come with Visual Studio. This is MDK's little bundle of joy. You just create your script wherever you want. Just so you know, this is the default location. It'll put your source code in. So if you want to keep it somewhere else, change it now. Just hit create, and then first time you're doing this, MDK will ask you for your game binaries path. So for this, you'll need to go to a Steam library. So usually it's in your C drive, program files, and you would have Steam, then Steam apps folder. If your library is somewhere else, you probably know where it is. Since this is a VM, I just have this temporary setup where I gave it my Steam location from the main drive. So I go to Steam Apps, Common, and find Space Engineers, Win64, and give it that folder. And then just create new project. This will only happen once, and the only problem is if you pick the wrong folder. I have discovered that apparently, sadly, I didn't find a way to change the setting. It's probably somewhere in the files or in the registry. But worst case, you can just uninstall the extension and start a new project. Anyway, this is taking a while because, as I said, VM. But there is one more feature of this that I want to show you, so I'm gonna wait for it to actually get going. Oh wow. Yeah, sorry about. I don't know what is up with this VM. It wasn't that bad before, I swear. Maybe OBS is messing with it. Come on. Oh, finally. Okay. So it will give you this skeleton of a code. It actually explains a lot of things very well. We will go through what this all does later, but one thing that you get with MDK is, let me just, yeah, if you right click on the project in your Solution Explorer, so the name of the whole thing, you will have this MDK deploy script button. If you click that, it will automatically prepare the script for Space Engineers, and it'll copy it on the drive, so you will have this script you made in your blueprints. So if you browse Workshop, you will see a blueprint of your script. So every time you change the code in here, you can just deploy again, go to the programmable block in game, browse Workshop, and you should see the updated version of the script. So just load it back in, recompile it, and you're good to go. I won't even try it here because I don't have anything properly installed here, but that is the gist with MDK. Basically we want it for this, and it will also automatically prepare everything for the autocomplete to work properly. So really, if you're gonna script in Space Engineers, get Malware's extension. Also, speaking of malware, on his GitHub, if you go back to the root page and you click on Wiki, Malware made a great documentation for many of the things in the PB. As you can see, there's a lot of content, and it will explain stuff about the plugin itself, about scripting in Space Engineers. He has some example code. For example, if you click your first script over there on the right, it will actually give you some code you can play with and explain what it does. So yeah, this is basically how I learned many of the specific Space Engineers scripting myself, so I highly recommend it. And yeah, give Malware some love. Also, if you ever are stuck, Malware is hanging out on Keen's Discord in the Programmable Block channel. So he always likes to help. Digi is also around there. You probably know him from a bunch of mods he made. So yeah, the community is really great. So if you're stuck, you know, you can ask me on the TMA Discord, but you can also always go on Keen Discord and find some of those guys. And they are really, really nice people over there. Anyway, let's get Space Engineers up. Because we want to see what we're doing, right? So let that bastard load, and let me just run my IDE. Oh, yeah, thank you Space Engineers for coming to this desktop. I really wanted that. Go away. What did I do now? 1 second. Let's pull this in here. Oh, and Space Engineers decided it's good time to crash. Lovely. Yeah, it does that. It's Space Engineers, what did you expect? Yeah, let's let it load without fiddling. It can be a bit iffy on Windows, let alone like this. Let's load up my scripting world. Play a little game of Loading Simulator 2021. Hopefully won't have any crashes, because if we do, well, as you can see, it takes its sweet time to load. Okay, there we go. There's my world. So, since we're gonna do the very basics, all we're gonna do today is we're gonna mess with these lights in a variety of ways, from the programmable block, obviously. So let me just see how my thing got set up. Sorry about that. There we go. Okay. So we're there. Well, basic grid, we have the PB because of course we need one. So let's get into the code. That's not what I wanted. There we go. So basically this is the only part. Let me zoom that in so it's going to be easier to read. This is the only part that will end up in the programmable block. So the rest of this is just boilerplate. MDK will do this, but it will strip it automatically if you use the deploy feature. This is just so the IDE knows what it's doing with the code. So 3 main sections that are already pre-populated for you, even if you just look into the PB and hit edit. It always gives you these. It gives you program, save, and main. So what's the deal with those? The program section is what's called a constructor. So basically this runs when your script spawns for the first time. So every time the script is recompiled, it will run the program section code. It will only do it once, so if you want to do anything else, well, you're going to use the other sections. Save is only used when the game is saving, or if you hit recompile, it will run this code just before it compiles the code again. Now main is the function that will run when you trigger the script in some way, be it periodically, be it from a button, be it from the terminal directly hitting the run button, whatever you're doing. So the first thing you always want to do is you want to be able to grab some block, because, well, you're going to be working with a block. So your best friend in this whole scripting adventure is going to be what's called a grid terminal system. So this object basically lets you access other blocks. It's the equivalent of the terminal in-game. It's just a programmatical interface to that. So if you hit period after this, you will see my IDE already lists some stuff we can do with it. MDK will do the same for you. So you can see you can get blocks, which will get all the blocks. You can get your groups, you can get blocks of specific type, and all that stuff. So to start with, let's get our light block, first of them. So we will get block by name. So if you look at the hint, when you do it, hold on, let me do it again so you can read it better. Returns the first block found with a given name. Will return null if no block with that name can be found. So if you do get block with name, and then in double quotes you give the name of the block you're looking for. So let's, in this case, let's go check in our in the game. So we know what we're doing. So this is, I call this one light terminal. So if you check in your terminal, that is the name that I renamed it to. So this is what we want to search for here. So now it will get the block, but we're not doing anything with it, we're not storing it. So you need to store it to a variable, which is basically just storage. Any kind of data you can store in a variable. To make it easier, you can just, in this situation, you can just use the var keyword, and it will automatically figure out what you want, what you are storing in it. So we're just going to call this var light equals grid terminal system get block with name light terminal. So now in this light variable we have access to our light. So now if I type in light and hit period after that, as you can see, it gives me some options on what to do with it. Now it's a terminal block, so it's now a generic block. It doesn't know it's a light. So it's just going to give you the generic things that every block can do. So in order to make this a light, so the game knows what it's working with, if you just do parentheses before your call to grid terminal system get block with name, and then you tell it it's my interior light. So this is the way the code sees a light block. Well, the interior light block. So if you're now the thing is, how do you know what the name the game has? Well, basically, the easiest way is you just type in IMI and let the autocomplete show you all that starts with IMI. This is how all the blocks are prefixed in Space Engineers. So most of the stuff makes sense and you'll be able to figure out what it is just from reading. Some of the things are weird and you'll just have to learn what they are. For example, a rotor is a iMotor stator is your actual rotor block, and the iMotor rotor is your rotor head. It's just, there are some inconsistencies like that, but sadly that's something you'll have to learn. There's actually no way around it. So sorry about that. Hello, Captain Arthur. So now if I type in light and hit period, as you can see, it now knows it has a fall off setting. It knows the radius setting. So you can change the properties of this light using these functions. So just to start with, we'll just set the enabled to false. So setting enabled to false on any block just basically turns it off. So if I now take this bit of code, I go to my programmable block, hit edit, we'll paste it in. The indentation is weird, but ignore that. If we hit check code, we see compilation successful. If you made any errors in your code, it will tell you here. Now the thing is, most of the errors will already be caught by your yeah, okay, Grumpy Granddada, see ya, maybe next time you can catch it live. So if I just, accidentally hit space here, you can see it went red. So that is why you want to use an application like this. It'll tell you most of your problems ahead of time. So let us just now hit run on this programmable block, and as you can see, the light went off. Now we didn't do anything special. Of course, you can do that from the terminal, you can do it with a timer or a button, but it's the first step. It already does something. And of course, turning off and on blocks is something you're going to do a lot. So since I don't have a way to turn it on from the code now, I'll just turn it on manually. So that's basically the basics of working with blocks. You need to get to it somehow. By somehow I mean you always go to grid terminal system. Now there's multiple ways to get blocks. In this case we went for the specific name. So there's also a way to get all the light blocks. There is, actually let me just do it separately. Get blocks of type. Now this one is a bit more confusing at first. So what it expects is you need to give it a list of the type of block you want. So this is the syntax for doing that in C#. So it's list, then it's the less than sign, then the name of the type, and then greater than sign, and we give it a name. We call it all lights. Now you need to initialize this, but this is pretty easy with the modern IDE. You just hit equals space, and it should, even this Visual Studio will probably do something similar to this. It will give you the default implementation to just create an empty list. So just select that, end the line with a semicolon, and now as you can see there's no more errors. My IDE is showing me that I could use var for this, that's why there's a little green thing here. It doesn't really matter, you can use var, you don't need to use var, but now if we just get blocks of type and give it the all lights, now the code will find every block that's of type IMyInteriorLight on the whole grid and put it in the all lights as a list. So just to verify this, we'll create a for each loop. So the for each loop just lets you quickly get through all the elements in a list or a dictionary or any kind of structure. So in this case, we'll tell it we want to go through all the lights, and each individual light, when we work on it, we'll just call it light. Or autocomplete decided that's not a thing. Okay, it doesn't matter. So we'll just tell it to my interior light, which is one of the lights in the list. So this will, for each, will loop through all the lights, and every time it finds one, it will put it in this temporary variable, IMyInteriorLight. So every time the loop goes through, this variable value will change and will point to a different light. So if we just do enabled equals false in here, and let's just nerf this code. Let's comment it out so it does nothing. If we go here, let's put the new code in. We check it, compilation successful. Okay, and I really should have turned this PB. Actually, let's do that. Let's make it easier for ourselves, so we can see what's happening a little bit better. So if I run this code now, nothing happened apparently. Oh, I did not hit recompile. I did not hit save changes. That I delete. No, I deleted the programmable block, of course. I'm sorry. Recompile, and now all the lights are off. Now I won't go through every method, but you can see that if you just type in, as I said, grid terminal system dot, as you can see, there's also get block group with name. So this is the way to find all blocks in a specific group. So you get all that. Get block groups will return all the groups. Basically, every method you pick will show you a little pop-up showing, telling you what the function does. So let's get rid of this now, and let's address why I called these. Oh, sorry about that. The reason I called all of these in this specific way is there are different ways to run your script. Now, those of you who played longer will remember you had to set up timers to continuously run the script. You don't really need to do that anymore. So we'll go through some of the ways to actually run your code, so you don't have to click run in the terminal all the time. I will have to leave you for 2 minutes at this point. I'm very sorry, but I have a work call, and sadly I'm on call, so I will be back in just 2 minutes. Sorry about this. Okay, crisis averted. Sorry about that. So, where were we? Oh yes, different ways to trigger the script. We already saw run from terminal. There's trigger, which is triggered by a different block, like a timer or a sensor block. Once will only run the main function once on the start of the program. Update 10 will update every 10 cycles, and update 100 with the update every 100 cycles. Now, about the cycles, there's 60 cycles each second in Space Engineers. This is not tied to a frame rate. Even if you have 200 frame rate, it will still trigger only 60 times per second. However, it can be slower if your game is lagging, so do not use that for precise timekeeping. There are better ways to do that, but just for keeping the script running relative to the game speed, it does the job. It's basically the equivalent of setting an infinite timer, which is what we had to do ages ago before that function has been added. So the programmable block can actually figure out which way it was called. If you look up here, there's this update type parameter that is passed to the main function. So to check for that, it's a bit weird, it's a bit wonky. If you know anything about programming and how binary flags work, you will understand it. If not, it's too deep of a subject to go into here. You can just learn the syntax and apply it. So what we can do is we can check the update type, but the way we check it is if update type and that's a single AND character, and the ID, sorry, not the game, is already, as you can see, suggesting things to me. So we'll tell it if its terminal and terminal is not equal to 0. And you need to actually put these into parentheses, otherwise it doesn't know what to do. So it's a bit of a weird syntax, but basically what this says is if the update type is terminal, or in short, if the user clicked run in terminal, then execute this code. So what we will do is we will get our light again, which I deleted. Let's call this terminal light actually. We'll go grid terminal system. Oops. Get block with name light terminal. So just like before, we now have the reference to our light in this terminal light variable, and we'll tell it terminal light. Oh right, I forgot, we didn't cast it. See, makes mistakes like that all the time. I'm my interior light. Now it knows it's an interior light. So we'll go terminal light. I don't remember, does it have toggle? It doesn't. There is a way to get to the toggle command, but we'll cover that later. So we'll just set enabled to something a bit funky if you never did programming. We'll tell it that it's not terminal light enabled. So in programming, the exclamation mark usually means not, a negation. It's the same thing for comparing stuff. If you said something is, if you type in this means not equal. So, but in this case we are just flipping the state of the light. So what will this effectively do is it will read the current state of the light, if it's on or off, switch it to the other state, and then set the current state to that. So this is basically, I pressed the wrong shortcut. This is basically a toggle switch now. So if you go in here, we check this code, run it. So let me position myself so we can see the light. we're not really seeing it. There you go. Every time I run it, the light will toggle. So, just to prove to you, this is not gonna work from anywhere else now, since we told it it has to be triggered to terminal. I will get a timer block. We're gonna need one for later anyway. And let's set it to run this programmable block, and then start itself again. And let's set its delay to 1 second, and let's start it. So as you can see, it's ticking, but our light is doing nothing, even though we are running the programmable block. But if I go in here and I click run, there it goes. Let me just set this to silent, so it's not annoying us. So what if we do want this timer block to actually do something? In that case, you can take this, let's copy it over, but this time let's set the update type to trigger. So trigger covers triggering from a timer block, triggering from a sensor. For example, if you want the light to turn on when the player enters the sensor radius. Again, this is all stuff you can actually do with the blocks themselves, but this is just the basics. You can build upon this. So let's just rename this to trigger light. Oops, I typed something in weird. And as you can see, it's complaining that it doesn't know what the terminal light is. But we will now get our light with the name light trigger. So let's grab this code, back to the game, let's edit it, check code, compilation successful, and as you can see, this light is now pulsing because we have a timer that is starting itself, running the programmable block, so running a loop, and it's doing that every second. So that's basically the trigger type. Oh, hello Mazarim. So for the next three types, once update 10 update to 100, there's also, by the way, update 1, which will update every cycle, but you should avoid that if you really don't need it, because it kind of kills the servers, and also we won't be able to see the results. It's going to be too fast, so I omitted it here. Now, however, to get those working, we'll need to tell the program to actually use those functions. So in this case, what you can do is set in your program section. So when your program first runs, you want to set runtime update frequency equals, and then you can tell it what kind of updates you want to use. So we'll just give it once, meaning once the program runs, it will trigger this and then never do it again. So let's just grab the code again. We'll change our update type to once. Let's make a new variable. We could technically use the same one because everyone is encapsulated in this if, but this is cleaner, just so you can follow along it more easily. We'll call it light once. And that should basically do it. As you can see, it's not that hard. Let's check the code. Let's recompile it, and you can see the light once is now on. Now, but if I recompile this code, it ran once again and it toggled it back off. So it's basically, if you want something to happen only once when you start your script, you can basically either do it in the program section, because that will do the same thing, or you can do it into one section. There are subtle differences, but most of the time they don't matter. It's basically a matter of preference, which one you want to use. So for the other two types, it is just the same thing. So it's update 10, call it update 10 light. Light update 10 is the name I gave it in the game. Now, here's the thing. If you want to use more than one update type during your game, I mean the periodical update light, you could just change this to update 10. But now we lost our once update type. If you want to use both or three of them or whatever, what you can do is type in a single type character and then add another update frequency. So this will actually make it so both once and update 10 are active. So if we grab this code, and it's getting a bit long to copy, but we'll be fine. We'll paste it in, check code, compilation successful, good. And if you look at this light, it's blinking pretty fast, because this is happening 6 times per second. Again, it's update 10 and there's 60 cycles in 1 second, so it's gonna update it 60 times, 6 times each second, sorry. So just for the completeness sake, we'll do the same thing with update 100. Just rename our light, and it's called update 100 in the game, and we need to add this to our list of used updates. Oops, that is the wrong key. There we go. So let's just edit this, recompile it, and there we go. So this is updating once every 1.25 seconds-ish. My math is not really good right now, but that is basically what is happening. It's the same thing as 10, it just does it every 100 cycles instead of 10. And yeah, basically there you go. That's basically how you get your script running, how you get the basic block, how you do basic stuff with it. Now, one thing is just using the enabled thing. Now, as you know, various blocks have various controls, and many of them actually have actions that are not directly available by using just a property like this. So there is a way to get all the actions that a block has. So let's just use our update 100 light, and what you can do is update 100 light get actions. Now it also expects a list to put stuff in. So the same way we did it before with getting all the blocks of a type, you need to make a list, and if you just open the parentheses, it will tell you it wants a list of I terminal action. So basically just type that over, I terminal action, we'll call it actions, and again just let it create this syntax for you to initialize the list, otherwise you'll get an error, and just tell it to go into actions. Now, so remember we had the for each, we'll tell it to for each through all the actions, we'll call each individual one action, and what we can do now is use echo. If you ever seen a script put data in the right side of the terminal, like showing the running status, it's using echo. Echo basically prints, let me switch to the game. Echo basically prints data into this area of your programmable block terminal interface. So I could just echo action, hit period, and it will tell me there's a name property. Now you see it's complaining. Anytime you try to echo something and it's complaining that it cannot do it, it probably just needs to be a string. And if I hover this is system text string builder. Luckily in C# pretty much everything has a toString method, so just call that, and there we go, it stopped complaining. No more red squigglies or anything. Let's grab this code. There you go. So now you have all the action names that are available. This is, however, the readable names. There are also names. There's also the ID. Now, it's maybe a bit counterintuitive, but ID is actually the in-game representation. That's what you want. So the name is just readable. You can verify you got what you want with that, or display it on the interface somehow. But if we pull out IDs, you can see we get these. So for example, we have increase blink offset, decrease blink offset, like all the things you would get in the terminal here. And it seems like they have spaces in there, which is surprising. I didn't know they did that, but okay. So let's just use the on-off action. So the on-off action is basically toggle. You see you have on-off on, which is turning the block on off off, which is turning it off. On-off is just a toggle, basically. So what can we do with this? We now know it's called on-off. Let's remove getting all the actions. What you can do now is update underlight, get action with name. Now even though it says name, it wants the ID. It's a bit confusing, but you can get this action and then you go period apply, and now it's asking what to apply it to. So we give it the update 100 light again. Now we can remove this, hack with it, and this should basically be the same thing. Now honestly, the way we did it before is easier. Again, this is not practical examples per se, it's more of a... So we check here if we get any errors, we didn't. And our 100 update light is actually behaving the same. So if there's an action a block can do, and it's not shown when you do your variable, then period, and if in this list you cannot find anything that's actually what you want, you can always use first, so get actions in a for loop, and then just get action with name, put that ID in, and apply the action. This is most often happens with modded blocks because they don't have the scripting interface. Oh yeah, sorry I wasn't following the chat. Yeah, it's 1.66 seconds. Yeah. I will probably put it on YouTube. I will also actually all of this code I will add those get actions debug things back in, and I'll put it all in a public GitHub repo, and I will link that along with the video, so you can just grab the code and mess with it without having to type it out yourself. Yeah, okay, the last thing I wanted to cover is It's all fine and dandy that we can get if the light is enabled. In this example, there are many blocks where you get this kind of output. Now, the battery itself is actually fine. It actually does give you most of this, if not all of this, through the interface. But sometimes you have some data in here that's just not available anywhere else. So it's just not in the interface of the block. It's also very common with modded blocks because they don't bother with scripting interfaces. So there is a way to deal with this. One of the things you can get from your block is detailed info. So detailed info is actually the same exact text that is shown here. So what you can do is you can store this into a variable, and it gets the current data from the detailed info section. Let's actually do that for the battery here, because the lights have no detailed info. So let's say our battery equals, and let's just for the simplicity's sake right now, we'll grab this battery, let's rename it to just battery. Read terminal system, get block with name, battery. And we will also, as before, cast it to my battery block, so it's now a battery block, not just a generic terminal block. Oh, for reference, yeah, generic terminal block is basically what you see here. If you select different types of blocks in your terminal, you see you can only get a subset of all the options. That's because these are the common options that are shared by pretty much every terminal block. But if you just select the battery, you also get a charge mode, for example, which is specific to the battery. So that is why you want to cast it to a specific type. So let's say that our info now equals battery detailed info, and now let's just echo all this out to our programmable block just to verify it works. So let's copy all of this code, let's go into the game, open the terminal, edit, paste, check code, OK, and there we go. It is now updating this actually every 100. There you go. As you can see, the current output is changing. It is reading every 100 cycles and updating what it's putting here. So this is also something I will include. Just in the so most of the detailed info is in the same format, as you can see here. It might not always apply with some modded blocks or stuff, but you can see it's always lines with a colon in between values. So you can press the wrong button. You can actually get this into something usable. So what you can do is, first, you can split it into lines, which you can do by doing string. Oh, oops, I'm sorry, I keep forgetting this in C#. I do this every time. So name of your string dot split, and then it'll expect a character by which to split it. So in programming, new line is denoted by backslash lowercase n. So this basically means new line. So now we should have every line of our info in a separate string in this array. As you can see, it automatically made it what it needs to be. So if we now go, let's just, oops, let's do a for each, just so you can see every line, and let's echo out line is, and then we'll give it the line. Let's edit that. There you go. As you can see now it says line is before, as we set it in our code, so it's not just copying the data, we actually split it in individual lines. Now what you can do is, let's say for example, we are trying to pull out this fully depleted in text. No, not the text. We are interested in the 5 hours value in the fully depleted in. So what you can do is, now in the line, you have the individual line. You can do if line contains text. And what did it say again? Exactly, fully depleted. Fully depleted. So now we found the line, because we found the only one that's fully depleted. To get the value, the easiest way is to do one more split, but this time let's split it on the semicolon. So let's say, let's call it key value. I will explain why. Let's do line, let's split on the semicolon character, and let's echo out key. Now this is now an array, so basically it's same as a list, it's just a collection of values following one another. The way you access individual values is, if you have an array, let's just put some comments here, that contains strings apple, banana, orange. So this is an array with 3 members. 3 strings are living in there. So to access the first one, this is actually the 0th element, because all the arrays in pretty much every programming language, with some exceptions, start with 0. This is member 1, this is member 2. So what you want to do is tell it, okay, we have key value, it's split in 2. So the first part will be the first element, or index 0. The way you index it is with square brackets, and you give it a number. So we want the 0th index. And then we'll say value, and we pull the index 1, or the second element, and forget the plus sign. So now if we copy this over, and we check our, see, key is fully depleted in, and the value is 5 hours. So basically we got it. So since we are not worried about the key, actually what we can do is depleted in equals, we just care about key value at position 1, as we saw that's in our value, and we can actually call trim on it, which will automatically just remove any spaces in front and behind. And let's just echo your battery will die in depleted in. Oops, went too far. I think Space Engineers crashed. That is That is exactly what we needed at this point in time. Okay. While that is loading, well, talk amongst yourselves. I did get another call from work, so I'm gonna go handle that while the space engineers... Oh, wow! One time I need you to be slow, space engineers. Okay, it's gonna take a while to load anyway. So I'm just gonna go take care of that call. Be right back. Okay, well, crisis is not averted. I need to go to do stuff for work, but luckily this is basically where I wanted to stop anyway, so that's some good timing. Let's just check this. There we go. Now we get our custom value of your battery will die in 5 hours, which is actually the value we read from detailed info on the battery. So I think this is mostly enough to get you started with messing with some stuff. Again, I will try to get the code and the video up ASAP. I think the code will be up probably tonight. I will drop it somewhere on the Tiamat Discord, which sadly, if you're not a member, I don't have an invite link handy. If Remetep would be so nice to drop a link in chat, I will owe him a beer or something. Well, I didn't have the time to set up a bot or anything because, well, it's been a pretty crazy day today. But yeah, thanks everybody for watching. We'll probably keep going with this the next week. If you have any specific questions or you want me to cover any specific topics, do just contact me on Discord. Again, I'm mostly on Tiamat. Those of you who have my contact can DM me, of course. I see a lot of familiar faces anyway. But yeah, have a lovely rest of the day, guys, and yeah, I'm gonna go and sadly do work. Oh yes, okay, before I leave, yes, Captain Arthur. Oh yeah, Discord, sir. Hold on, you give me just a second, I will generate an invite. Oops, there we go. There we go, this is the TMI Discord. It's full of people as crazy or me or crazier. It's a fun place. We only bite if you ask for it. Okay, I do need to skedaddle now. I will get this encoded and uploaded somewhere to YouTube, and as I said, I will put all of this code and some additional tidbits that we showed but deleted during the work on GitHub, and that will be also linked on the Tiamat Discord. So see you guys next time. Enjoy. Bye.